Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 6, 2025, which was about 11 days ago, and this paper tackles hallucinations head-on. The standout result is cost. The GPT-4o labeling came to $535 versus about $3,000 for comparable human work, about 17 times cheaper. The paper is titled, When Models Lie, We Learn, Multilingual Span-Level Hallucination Detection with PsiloQA. And as we will see, the practical gains are surprisingly broad. Beyond cost, the dataset spans 14 languages with span-level tags, and fine-tuned multilingual encoder models beat uncertainty methods and large language model tagging while transferring well across benchmarks. Alright, Figure 1 shows the 4-step pipeline that creates PsiloQA from question generation to final filtering. Step 1 uses Wikipedia passages and GPT-4o to produce grounded questions and a golden answer. Step 2 elicits a hypothesis by having diverse large language models answer without context, which naturally induces mistakes on hard facts. Step 3 performs span-level inconsistency detection, meaning the system tags the exact words that conflict with the passage and the golden answer. Step 4 removes incomplete or subjective cases so the dataset stays clean and scalable. Well, Figure 1 showed the pipeline. Table 1 situates the dataset among prior span-level resources. Table 1 compares domain, annotation style, generation type, languages, model counts, and split sizes. PsiloQA stands out with roughly 64,000 training examples across many languages. By contrast, RAG Truth QA lists about 5,000 training items in English. MuSHROOM reports around 3,000 unlabeled training samples. It also includes nearly 2,000 test cases in multiple languages. Table 2 compares span-level hallucination detectors across 14 languages. The top uncertainty rows deliver moderate average precision but low intersection over union, which is a span overlap score that rewards precise boundaries. The middle encoder block leads because fine-tuned modern multilingual encoders consistently align spans better, with MMBERT taking the strongest results across languages. The bottom language model block performs variably, as fact score and Q and 3-shot tagging trail the fine-tuned encoders. So Table 3 shows that one multilingual MMBERT trained across all languages delivers stronger cross-language transfer than separate per-language models. The key idea is cross-lingual transfer, meaning a model trained jointly on many languages can reuse shared cues to help each one. In the PsiloQA block, the multilingual model raises both intersection over union and average precision for most languages. In the MuSHROOM section, the same pattern holds, which signals robust generalization across different scripts. So, Table 4 shows that models fine-tuned on PsiloQA English generalize better across other benchmarks than those trained on RAG Truth QA. The biggest gain appears on MuSHROOMEN, where intersection over union reaches about 59%. On the same benchmark, average precision is about 70%. Joint training helps on Hallu entity average precision, which rises to about 63%. FAVA bench stays low across the board, suggesting task differences that limit transfer rather than model weakness. Alright, Figure 2 shows how many dataset samples each generator model contributed, which tells us whether a few models dominate the corpus or the data is balanced. The chart skews left because several high-output models produced large batches. The tallest bars reach roughly 7,000 samples, so those models strongly shape the dataset style. Toward the right, contributions drop to roughly 1,000, which increases model diversity but with less influence per model. Alright, 2 takeaways stand out. Span-level supervision across 14 languages is feasible and cheap, and fine-tuned multilingual encoders like MMBERT deliver the most reliable hallucination spans with strong cross-language transfer. The broader implication is practical, safer multilingual systems, though precise boundaries remain tricky. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.